All right, so here we go. Substitution now with trig identities, all right? And so what we're going to do is let's just look at this first guy right here where we've got dx over cosine squared 2x. And remember that what this really is if we think about cosine squared 2x, that's the same thing as secant squared 2x. So what we're really working with here is the integral of secant squared 2x dx. But again, when we start to do our integration, we can't handle just a 2x in there. We've got to sort that guy out. So we're going to let u equal 2x. du is going to be du dx is equal to 2. So du is equal to 2 dx. And remember, we want an equality statement for just dx, okay? Look, I've got secant of u. I've just got 1 dx. So I just need just dx right here. And that's when I'm going to divide both sides by 2. So d, or 1/2. Multiply both sides 1/2 or divide by 2. So that gets me this part. What I'm going to integrate then looks like this. 1/2 of secant squared u du. Okay. Now, this one we can do. The 1/2, since it's a constant, can move in front of the integral. So it's 1/2 secant squared u du. And secant squared is one that we know. In fact, it's on that little handy-dandy list of rule sheets. And if memory serves correctly, it's tan u. So 1/2 tangent u plus c. Oh, by the way, u has to be replaced. So my final answer then is going to be 1/2 tangent 2x plus c. And if you take the derivative of that, you'll be good to go. It won't be a problem at all. Okay? What about this next guy, cotangent squared of 3x? Well, if you look on, on whatever trig resource you have with different trig identities, cotangent squared of 3x is equal to cosecant squared of 3x minus 1. Okay, so we don't have anything that works us out with cotangent squared, but we do have stuff that works us out with cosecant squared. So my integral on this guy then is going to end up being cosecant squared of 3x minus 1 dx. All right. Well, how do you handle this situation? We can let this guy right here be equal to u. So u equals 3x. du dx is equal to 3. So du equals 3 dx. And 1/3 du equals dx. So there's our equality statement. And again, because we just have the one dx right here. Okay, so let's go ahead and sort this out. And this guy's a little bit interesting because we can actually look at this in two ways. We can look at this as cosecant squared 1/3 cosecant squared of u du minus 1 dx. Okay, and why can I do that? Because when I integrate, if I have a plus or minus sign, I can separate my integrals into those different pieces. So that's what I've done here. And now we can integrate. Well, if you integrate cosecant squared, you end up with negative cotan. So this guy's going to be negative. So 1/3 times negative cotangent of u minus, and then the antiderivative of 1 is just x. And then what is u? U is 3x. So 1/3, negative 1/3, cotangent of 3x minus x. So there's the first two guys. I'm going to need a little bit more room for this third guy, so I'm going to pause the video, clean this up a little bit, and work out this third one, which is a little bit more involved.